Hey everyone, welcome to Decoding Digital Age. I'm Anuj. Today's video is going to be super exciting because I'm going to break down retrieval augmented generation from scratch. So after the end of this video, you will be able to answer what is RAG and why it is used, traditional LLMs versus RAG based system, real world analogy to understand RAG, and then the architecture diagram. In this architecture diagram, I will be going to explain each and every component in detail. Then at the end, live RAG running pipeline. RAG is a system design pattern. So in order to build some application, we need design pattern, right? Like we need system design pattern in software engineering. Similarly, for building AI application, RAG is one of the system design pattern. It's a combination of three things: retrieve, augment, and generate. These are the most important things. We can also say the pillar of RAG. The most important reason behind the existence of RAG is because it handles the limitation of traditional LLMs. Let's understand all these with a quick example. Suppose there are two students, A and B. They study in some college and both of them attend regular live classes taught by the instructor. But it's a very common scenario that sometimes teachers missed out some concepts to teach in live classes. So they give some extra study material or notes to students a few days before exam. But what A did is he only relies on whatever he was taught in the live classes. So B, being a smart person, he also studied the notes provided by the instructor, so he's having some more context, and he also rely on those context and answer the questions more accurately and with confidence in the exam. But A also try to answer the questions, but because without having the knowledge about those concepts, he starts hallucinating, which is a very common problem in traditional LLM system. So he also provide answers, but he hallucinate because he don't know the answer and he try to guess the answers, so it might be wrong sometimes. So that's in our case, A is working as a traditional LLM system, but B is our modern RAG system. Now let's understand some of the important terms related to RAG. There is a data source where all companies' data is getting stored, and there is an indexer. Indexer split those documents into chunks, into small pieces of data. Then it also create vector embeddings. Vector embeddings is actually the vector representation of the chunks of data. So there is vector databases. We have to use vector databases, like it can be like Pinecone or ChromaDB, or it can also be OpenSearch, Elasticsearch by AWS. So then there is a retriever. Retriever convert the prompt given by the user into vectors, into vector embeddings. Then it retrieve similar embeddings to the prompt from the vector databases. Then it combines that prompt and context retrieved by the vector databases. This step is also called augmentation. Then it sent this to LLM. LLM use that prompt and that context to generate the response. Now let's understand the architecture diagram. So as we have discussed earlier, this is our data source. The company will continuously be uploading the current information to this data source. Then there will be an indexer. This indexer converts those documents into vector embeddings and chunks. Then those vector embeddings and chunks are loaded to this vector DB. And whenever the user sends some prompt, the retriever firstly convert that prompt into vector embedding form, and then use similarity search techniques like cosine to fetch the uh, matching vector embeddings from this vector DB, and then retrieve those things. Those are also called as context. Then it augment that particular context and this prompt and send it to the large language model. Then using that particular context, using some extra information, the LLM respond to user's prompt, to user's query. This is the document that I will be uploading to Amazon S3. Here's some important information like email, website, and LinkedIn company's profile is listed here, right? So I will be uploading this to Amazon S3. I have already created the S3 bucket, and now I am going to upload the file. Let's click on upload, and the file is successfully uploaded. Now I just have to run this script. Now you will see a output folder here having the extracted text from the document. And see, this is done. The text is extracted. This is all the text from that document. Now we will use our chunker API to convert into chunks. See, we have got the chunks. This is converted into 5 chunks. Now we will use our embed chunks script. And yes, those chunks and along with this text is also saved in this file. Now we will have to store the embeddings using this script. And the name of the index is this, decoding index 1. Now this is successfully uploaded to Pinecone. This is my Pinecone setup. Let's see where that index is created or not. Yes, decoding index 1 is created. And these are the stored chunks. Now let's run our user query.pycode. Now let's give the query, how can I contact coding digital age via email. Now this is retrieving the context and it provides the answer. You can contact Decoding Digital Age via email at this. So now it's confirmed that our RAG pipeline is correctly working.